everybody, and yeah, the discussion I want to make is about what they are called, adapters for the chip that I have, and my chip that I have is called SSOP48. It means 48 pins. And I looked around on internet, and here on usually on eBay is a bit more expensive than on AliExpress. So I will not talk about eBay search findings. We are in 2023 right now when I'm making this movie, and this is the prices. Here is one model. But there are other models of this. Is a good one actually, and it's a bit more expensive. It's $6 the product, but also the shipping 2.5, and also the tax. If you are making this, putting it into the cart, probably, let's see if it will not fuck me. And shipping to, yeah, it says there 8.50, but usually they are adding some tax and some TVA tax, specifically for my country. Probably, I'm not sure about other countries, but that's how it works. eBay, it just fucked up everything. Unfortunately, they had the cheapest and the most reliable prices ever I've seen. But then from 2020, they fucked it up. Exactly when the coronavirus started, and after a few years after that, pretty much immediately, the Ukraine war, initiated by Russians on the borders of Ukraine. Poor guys, both of them. Okay, so so I will talk about the AliExpress. So I will close these findings on eBay because it's not relevant. This is interesting. Probably this is the cheapest, probably, but they are around that $60 anyway. And I did another search for this 10 pieces TSOP56 to DIP 56 adapter, because when I did search for 48, I got this. You see TSOP48 here, so here in the name you see it's 48, so they included that 48 for the search. When you are searching for 48, they will throw you this board that you see here, and usually I got this 56 is actually board, and I have it here, and you can see here is mentioned 56, but more important, here on the board itself it says there, you see 56, TSOP 56. It is not 48 at all, but you can use it as a 48. Now I'm not really sure how the distances are working. What is the difference between TSOP and SSOP? So this is clearly is a TSOP, and is also written on the board there, TSOP, but it's not SSOP but it's the most frequent search find. This is another board. This is actually SSOP, exactly what I need. So here you see directly on the board it says there. So it's an adapter, and it is SSOP, exactly what I need for my chip. And is this, you see here is mentioned, and also here in the first name. So this, but the problem is the price. You will see in a second. So we have four pieces plus shipping 8. It's around 12 or 13 dollars. Where are you? And this, the price is $60, around 60, plus shipping 6. So 66 something, you know, plus shipping 6, another $6. Come on, almost 7. So, but it is very interesting. Yeah, it is SSOP48, exactly what I need, but it's not TSOP like the other finding that I did. So this thing is TSOP, and I'm not completely sure if the size of the pins of the pads is the same size with the SSOP. I have no idea, and I hope they are the same, but they didn't name it differently just because. Yet I was on the verge, on the point to buy this very, very extremely cheap board. I guess here, exactly in the name, 10 pieces. So it's also mentioned here as well, 10 pieces for $251 plus shipping 1.19. It means $370, which is absolutely cool for the price. And I actually need 20 pieces for all the chips that I have, but I'm not sure about the distances between the pins and for the track itself. But another very, very important issue that I discovered is these two pins. You see, if you see this pin, and this pin is for it is mentioned here. Is mentioned here 56, 55 and 56, and here as well 1 and 2, 3 and 4 for the same line, you see. So these two pins are in line for 5 and 6 and etc. But if you have to mount them on a breadboard, these two pins, they are making short, totally short, because the breadboard lines, they have it's a single shorted line with 5 holes usually, and if you are inserting it like that, you are making short between these pins. So that's a very big problem. I thought about it, and I find a solution actually. So my solution is like this: to insert this first row of pins into the breadboard, you know, but the second line of the second column of pins from here to drag the wires, you know, like this, and dragging wires to other lines of pins. So pretty much this is doable. I can do it very easily actually, and it's dead easy to do it like this. And it's very, very interesting solution that I find. But of course the numbering is totally fucked up. The numbering here is 1, the next one is 2, so here is 3, the next one, the wire will be 4. The numbering is very, very fucked up. I have to be extra mega careful to pay extra attention to the numbering. But it is a doable solution. I can use this. This was the next solution. Actually, this is fitting exactly my problem. It is covering my problem. But here is a problem as well, especially on the pins. It's a pad here, and then is a pad here. I have no idea how to link them. Probably also with wires, like I did my adapter. Let me show you my adapter. So here in the camera, yeah, this is it. This is my adapter that I have. I believe I can do it the same here, but the wire will rip off this very thin substrate of copper and yeah, it's not really ideal. This way of I'm not completely sure how to make it, how to adapt these pins that is having here to the adapter that I already have, or to the breadboard itself directly to the breadboard. I have no idea. So it's still a problem of pin out, but it is fitting the chip here very well. So that's a very good plus. Another problem with this board that I find is that you see here there is absolutely no contacts, no contact. I cannot link anything here. Probably I can scratch the green paint and reach the copper underneath this copper and actually link on top here. But I bet it is tiny as fuck, that little circle that is having there. And yeah, it's only having these pads, longer pads here on the back. So these are not really good designs, both of them. Neither this one is not good design for what I need, neither this is good design, but they are some options. In the end, they are options. Yeah, probably the pins are bent like an L. Interesting. All right. This is the motherfucker. the price is a bit too high comparative with this guy, a little bit. No, 6, whatever. So 8 plus 4 is 12, almost $13. $13 only for this board. Not really an option for my money and for the experimentation I need to make. I'm not sure. I am stupefied. I am amazed how difficult this little shit problem it is when you get to the details of it. This is just stupid. The price is just stupid high. It's stupid high. And I find another one with $300. Unbelievable. And the idea that I got, that I was thinking on, the numbering will be fucked up quite significant. This is another one that I find on internet. This is exactly what I need. Look, the product is discontinued. It says there. This is the other one with $325. It's nothing. This one is $59.99, around $60 on AliExpress, as you can see. But it is exactly what I need, and but it's too expensive. I believe I covered everything, and I will see what I can do. Thank you very much. This is it for this part. All right. Bye-bye. All right. Hello to everybody. Hello to everybody. From Romania, from your favorite artist, electronist, Mr. Q12 here. I have a project. This I actually planned it for a very long time. I got the chips for, I don't know, for 1 week already. These are the chips, and they are extraordinarily tiny. Do you see how the distance between the pins are? It's insane. And they have a ton of pins, a ton of them. Actually, they have this particular one is having 48 pins, and the problem is that I have 20 of them, 20 chips, 20 integrated circuits like this, exactly like this. And this is for driving a multiplexed LCD, and theoretically, from the electronic point of view, how to link the pins and everything is very easy to do. But internally, how the logic is having a memory inside. I have to deal with registers. I have to deal with a lot of stuff, serial stuff that I have to address and to bypass and to look on some codes. Everything is code. It is made from code on these chips. So I have to deal with them in code, not from hardware at all. The hardware is very simple. But the other point of view, the other problem that I currently have are these very tiny legs and spaces between the legs. And I looked everywhere. I looked on internet already. I did my homework. All the adapters that I find, they were either stupid or very expensive. The correct adapters and very expensive, or very stupid adapters and very cheap. And I don't want stupid and cheap. So my plan, I already made a test here. I put these 2 bars. I already started to take out the pins from this bar and insert them here. As you can see, only 2 pins I managed to insert. And as you can see, it's pretty good. For a prototype that I'm making here is a piece of wood, and it's and here is how they are getting into. Let me do it like this. So you see, doesn't matter. The distance is good because I measured. I actually put this guy here and I measured each pin. You see, it's a mark per pin, and I did manage to solder those, and it's quite good. I was scared of the length, that it will not be enough, the length of the leg. But after some thinking before I started doing anything, then I realized that I can make it flush with the board, with the wood that I'm having here. Then when I put it in practice, I started with this one, which is in the corner here, which is the very sensitive, the very weak pin, the weakest pin, because it's here in the corner. It's having this side and this side on the top and on the left, and this sides can break usually, but because I have a very thick material here, it's quite secure there, and I can stress it. I can and what's most important, when I push it into the breadboard here, is not coming out through here, and when I'm dragging it out, is not remaining there. So it's quite securely catched there. But to do it like this, I had to do it in a special way, and I will show you in a second. Here is, you see, this drill. It's a very sensitive drill. It's very this is a box that I'm having with different sizes, and this is 0.6. I actually measured this pin with my caliper, and with my caliper here and with my micrometer. It's actually 0.63 with the micrometer, and I got this 0.6 drill, and I mounted it here, and I made the hole. the second hole didn't get perfectly perpendicular. It got like that a little bit. So I enlarged a little bit the hole with 1 millimeter drill, and the pin was doing like this, floating around. What I did, the body of the pin, I put some with my soldering iron. I put a little bit of soldering, and it got a little bit more fat. And when I press it there, it kind of pressed itself, kind of. And then, as you can see here in the drawing, I'm drilling with this guy here with 1.5 millimeter. It's double of the 0.6. That is 1 millimeter that I had before, and this is the 1.5. Of course, this is greatly exaggerated here for you to understand what I did. So this is the 0.6 hole that I made it with with this drill here. So it's this hole, and this larger one is with 1.5 here on the top and here on the bottom as well. So I made like a cap, but inside, like a little hole, and that little hole I could enter. I couldn't enter actually with my soldering iron because my soldering iron is very, very thick. You see how thick it is? It's very, very thick. I could only. So if this was the hole, this was my soldering iron, like that. So I could only do it here in this area. I could. So the pin was inserted, and I could heat up the pin and some solder. And it was like this, the solder. It was like but not inside. And to push it inside, I made this contraption here, which is not very. I'm not very proud of it, but is an idea. And believe me or not, it worked. It kind of worked. So I took a piece of wire. I actually measured this wire, and I don't have other wire than this. This was the only one that I had, and it was thin enough to enter between the pin, so the thickness of the pin and the margin, this margin here of the wood, so to enter between them. I have to keep it very, very short here, because if it's too long, it's not doing the job properly right now at this height that is having here. But if it's even longer, nah, it's useless. So I have to keep it very close to this heating element that I'm having here, which is eaten. I managed to eat it to damage it, but yeah, well, it's good enough. I managed to enter with that little wire here and all around, and I literally made like I'm steering around the pin, and it worked. It bloody worked. I cannot zoom in to actually see. So my idea was to create a blob there in this holes that I made, a blob of solder. And my idea, it seems to work. Here the pin is actually. The pin is actually right on the margin, but it's not really visible, and it's surrounded by a little bit of solder, a blob of solder, and that's enough to hold it from, moving up and down when I'm. And of course, I will have to cut this material as well to this length that I'm having here. So far, this is the middle of the night right now, and I'm making some holes with my drill press that I'm having, which is very silent, of course, and also this motor, which is infinitesimal silent. It's very, very extremely silent. But I'm doing it, so don't tell anyone. So far so good. What I'm doing, the process that I'm using it, is because I know for sure. So let me put this back. I know for sure this machine that I'm having here, the motor that is having, is not a three-phasic motor. It's one phase, from what I know, and it's heating up extremely fast. So my process of doing it, all these holes that I'm having here, and also on this side as well, I'm making the hole with this drill. The motor is heating up a little bit. And when I finished making the hole, then I came, I get using this with my power supply that I'm having here, this 5 volts, it remained open all this time, and I'm connecting these two pins. I'm using this to enlarge, to make these little holes here and here, and then I'm starting to heat up my two of them. I'm using them in parallel. I'm using them both because this I'm using it to heat up and to add a little bit of solder, and with the other one, with the wire, I'm pushing the solder and I'm steering the solder around the pin until it's starting to catch there, and I'm filling the entire hole. And because it's wood, this resin, it's my hope it's really my hope the resin will be sucked into the material, into the wood, and being sucked there, also the solder will be sucked a tiny little bit, so it will adhere to the wood as well. It's my hope, but in reality, I don't think it's happening as I imagine. But that's the idea, adding this resin there. And so far so good. I mean, it formed a little blob around the pin, like a sphere, and then when I stir it, it kind of dissipated and entered in the hole as well, and most probably along the pin. I hope the capillary effect did its job to suck a little bit of solder when I was steering there in the margin, and also here. I don't steer too much. There is a very important problem that I have. After this very thin wire got heat up, when it wasn't heated up, it was quite strong. But now, after I heat it up, this little wire, it got very, very soft and very weak, and is bending way more faster now, and is more fragile than it was originally when I first put it. So that's a problem. So it's bending very fast, and it will break soon, and I will have to wire everything probably, or dewire something from there. And I'm not completely sure how much it will resist there, because it got extremely weak right now. Unfortunately, that's an unfortunate thing. So this is this will be an adapter, and its name is SSOP48, because I am having 48 pins in total here. So 24 on one side, and it's what I'm having right here. I have to make 24 here and another 24 there. If we are making the mat here, this kind of adapter, it's extremely expensive, especially if I want to buy it in larger numbers. If it's only one, it's something like $7 or $11. I find it on $7 it was the cheapest, and most of them are like $11, $12. So the cost of the board plus transport, that's why it's so expensive. And also, yeah, well, they could have make it more cheap, but yeah, they didn't want to. And what I'm doing here is this adapter, and is this number for 48 pins, and I really hope it will work. If it will not work correctly, I'm screwed. I will work like an idiot. Yeah, we will see in the end how it will get. The plan, how I'm thinking to mount it is like this: is to place this guy here, to glue it probably a little bit, and then to drag very, very thin wires to each pin. You know, from this small pins that is having to their corresponding pin on the side, and that's how I'm planning to make it. At least this adapter will be ready for testing, and it's also I calculated it here on the breadboard, and it is fitting extremely well here. It's very big, but it is fitting here, and I can drag wires from this last line, and also probably that line that I'm having there, but I'm not sure. Probably also from underneath it, I'm not sure, but for sure I'm leaving at least one line of holes. So the wood is covering this line, the second line that's having here, but is leaving this first line. The same is on the other side. I really hope it will be okay in the end. I really hope. We will see. But so far so good. This is my project. This is the challenge. It is a challenge, and I'm absolutely not sure if it will actually work until the end, because I already made some mistakes on this second one when I enlarged that hole. We will see. Wish me luck, and let's hope I will manage to make it good enough until the end. Thank you very much for watching. This is the end for this part. All right. One important detail is that I am forced to use the pins as you are seeing here, and these holes here, and you know, I'm forced to use them like this, in this manner, because the thickness of this material is too much thickness, and I don't have a thinner material. But I believe, I mean, in my mind, the thicker the material, the better. Especially in this case, I really want some stability. But I wished the pins were a little bit higher to actually get out from these holes that I made here, to be a bit more higher to actually link the wire around and the pin a little bit. But yeah, I needed the pin to get out on this side here to be long enough, and that's a problem with this design. I really wish those pins were a little bit more high than this. And I managed to make the third pin to mount it here. What I forgot to say is that all that I'm making and all that I'm filming and everything that I'm showing, my endeavor and my prototypes that I'm making, and the hard way I'm doing this stuff that I'm making, it's a proof that you can do it if you want. If you really want it, you can do it with the material that you have, with very cheap material. And if you really want it, you can do it. That's all my entire idea that I want to transmit to the future, to the future generation. All right. Doesn't matter how hard it is. All that matters is to be made, to be done. That's all that matters. Doesn't matter how hard it is. All right? Don't get discouraged easily. Get in the hero mode and start building your stuff, and little by little, it'll get done. Another detail is that, like I said before, I'm making this small hole here. Then I'm getting to that drill size, and I'm making these two holes. I'm inserting the pin. I'm putting the solder, and then I'm starting again. As you can see, one by one, again with this drill, and then we did that, and then inserting the pin, putting solder, and one by one, I will make it until the end, until the 48. Holy shit, they are way too many. All right, that's the other point I forget to mention. All right. That's it for this part. All right, a little bit of update. I changed that wire. This is the wire here, and this was the rod, and I changed it with a needle, and the needle got red hot internally inside here, but here on the margin it wasn't that great. And when I took it out, I noticed it was red hot, and yeah, I tried with that needle and it didn't work. And then I took out a tiny little bit like this long copper wire, and I file it. I made it with a point, and now it's way more better. Way more better. I mean, I can reach inside the hole, inside the hole, and yeah, it can melt quite good. I'm not sure if you can see anything, but that's this is the update or the upgrade that I made. This little bit of copper wire that I put there, and it's good. It is better than before. All right, that's it. This is my two irons that I'm interchangeably use. Yes, a very small update, very small. A couple of days I couldn't work because I had to install Windows 11. I had to upgrade from my Windows 7 that now in 2023 I use it until now, and I can say Windows 7 worked better, way much better than Windows 11. Windows 11 is lagging, is having a ton of errors, a ton of problems, and it's pretty much an annoyance, and I have to deal with it. I have to support it. But it's probably my first impressions. After using it for a couple of days, I stayed and installed a ton of programs. Well, not that many programs. I didn't install that many programs, but I had to customize a ton of settings in especially in Windows and in for some programs that and I'm happy that some programs, old 32 bits, not 64, old old programs are still working. But I have a ton of very serious problems in Windows 11, and I'm not that happy. I want to believe that I will finally, in time, day by day, you know. I will manage to make it work fine. Okay, so I had this Windows installing delay for a couple of days, and I couldn't work that much on this project that I'm having here. And this is the level that I reach. I installed only 8 pins. Remember, this is having 48, so 24. So here are 24. I managed to right now to put some holes here, but not the last 2 or 3 here. And let's see if you can see. Yeah, kind of. You can see there and there through the hole, but not there. Yeah, you can see the hole there. So the last 3 I didn't put because here is my drill. This got extremely hot, and I'm also afraid of cracking this drill. If I'm cracking it, if I'm damaging it, I'm totally screwed, and I cannot continue this project if that drill is. I'm very extremely dependent on that thing, and also my machine got extremely quickly, extremely hot, and I had to pause it. And I said, well, I should make an update of the progress, which is not that much, but I will show you the progress in time. I hope this project can be done. Theoretically, this can be done in 2 days if I have also proper, a little bit better, machine, the motor that is not heating up that quickly. You know, in 1 or 2 minutes, that motor got hot, continuously running and without interruptions. And yeah, it's not the best what I have there. And next, yeah, I'll have to drill with this to make this little holes, larger holes, and then yeah, I want to work a little bit more faster, but also careful, very careful with the drill not to break it in any way, because if that drill is breaking, project is finished. Okay, all right, that's it for this update. Bye. All right, absolutely radical change of plans. I had this 8 pins already installed. I installed the 9th one, and then the 10th one I was preparing it, but I stopped because it was dubious, very dubious. So if this is the pin was staying like this inside, you see, and but actually I push it a little bit inside, and here it was barely touching the solder, and it was a very high probability this could not make any contact. I don't know the reasons, but this little dinky that was coming out from this hole was no fucking way. I don't like it. Although I made all these holes here, I prepared them, and it's already damaged from that point of view. I don't care really. So problem number 2 was misalignment, and as you can see, probably you can see here on this side, it is aligned fine, you know, it's in a single line, but with very small deviations. But here it's with very big deviation, is like a zigzag like that, and some are 2 here, you know, and some are 2 there. And also the pin is not perfectly straight, is bent like that or like that, you know, because this I know the problem. This is moving when I'm pushing in, when I'm making a strong connection, when I'm pressing, is lifting. Is doing like that, and doing like that, the board was inclined as well, and the board being inclined, the hole got not perfectly straight, but a little bit at an angle, a little bit, and I got this bullshit piece that I'm having here is not really in a straight line. Not being in a straight line is affecting this very precise alignment that I'm having for the hole. So all those pins were making a very big problem with this aligned holes that I'm having here. I find a solution for this problem as well, because here is way more better aligned. All these holes are pretty straight. I could inverse everything. I could mount here the chip, drag the wires, and the longer leg here on this side, where they are very well aligned comparative with the other side, and they had more chance to fit straightly and not make any problems, you know, because of the misalignment. But third problem, and this was probably the decisive problem that I stopped because this problem, pretty much. I'm having this this line with all the pins, and it's not really pressed down. You see, it's not really pressed. It's kind of making contact, but not correctly, not entirely, and it's very hard. All these 24 pins that I'm having here, it's very hard to take them out from here in this form that I'm having it right now without pressing it too deep. It's very hard to take it out. Very strong. I have to be, and also to pressing it down is also very hard. There are too many, and I don't know the reason. It shouldn't be a problem, but in reality it is a problem of so many pins in these holes. They are perfectly aligned and everything, and it's still opposing some force, and quite terrible force, quite strong force. I have to press it or take it out, and when I'm trying to take it out, even the plastic is moving up a little bit. This black plastic, this is moving up on the pin, and this was and I knew it for a couple of days, and so I changed the plan. I took out all the pins, all that work in one day. I did all this work. I throw them away. I put them aside, and the next good thing to do was to cut some wires. I searched some wires here, and I have plenty there. They are copper wires, very good copper wires actually. This is scrapped wire that I'm having here. It's scrapped copper wire. The plastic is annoyingly melting, very quickly is melting when the copper is actually this is not a copper. This is not copper. It's only, yeah, if it's magnetic like this is not copper, it's iron based, and it's having a copper coating on top, so this is not copper, but it doesn't matter. The plastic is melting very quickly and is dragging, is you know, is is squishing itself back from the heat zone, and but I want to get rid of this kind of isolation that I'm having there. Of course, if I'm careful, I can kind of maintain the plastic not going too far. So what I did here is this. I can show you. I enlarged all these holes. Originally, I put a 0.6 millimeter hole. Also, another problem was the drill. I didn't want to crack the drill. My luck, I made all these holes with that drill and it didn't break at all, so it's fine. But I didn't want to push my luck with the next line that I'm having here. So I drilled everything with 1 millimeter standard 1 millimeter hole drill. And this is kind of a little bit loose here, is moving a little bit too easy. But it's okay. If I bend it a little bit, it's starting to get stiff, hard there. And also here, I measured this wire, and I put a hole. Actually, these are a bit bigger, but the rest are 3 millimeter. The smallest drill that I had, sorry, it's not 3 millimeter, is 0.3. I made that, and I made a hook. You see? It's like a tiny hook. It's a bend here, and I'm bending it into that small, very small hole. You know, you see? And I'm making with this. I'm making a little pad. You know, and the wiring will go to that pad, and it will be very secure this way. I'm very certain I will make a proper contact here. Before, how I had it like this, it wasn't that secure. It was no, I didn't like it. I didn't trust it. That's the problem. I didn't trust this design. So I made this new version. This is the upgraded version, and here you will ask me how I will stop being pushed when I will insert it. So my plan is I did think on this problem quite some time, and to push it and to get out from here, I will either bend it this way or in that way, and then I will make it like this and like this, and voila! In this way, the wire cannot escape from that hole at all, either pushing it or dragging it from here. And I don't need to drag it because I will explain very quickly. The next step is these pins and how to mount them into this breadboard. And I will not use this entire strip. I was thinking of it. Theoretically, I can, you know, like soldering this end of the wire to this per each pin. Theoretically, I can put the entire and mount it by eye, you know, like that, you know, even mounting it here in the very because the wire will permit to bend it around. But what I was thinking is to cut either 6 of them, like this 6, or probably 3 by 3, and have like little modules and tuck one near the other, because it's very easy to mount only 3 of them, or 6 maybe, comparative with the whole 24. So that's my plan. That's my design. This is my design, and this is my thinking, how I'm stepping back and redesigning the bastard, and seeing the problems and thinking forward a little bit what could go wrong, especially with this design. This design could go wrong here in the connection zone. Maybe not. Maybe it could have been okay, but this is more secure. What I'm having here is absolutely secure. And also, this pin mounting will be flexible. I can actually customize it to be very at the end here. And this will literally float in air because of all these wires will hold it in the air. And I don't care after that. You know? I only care to connect it properly there. I should probably make a little bit more longer wiring than this. I hope it will not be a problem. If it will be a problem, this length of the wire that I'm having here, maybe I will make another round with longer wire. I hope it will be fine as it is, because I'm using the minimum material that I can, you know, and build it with the minimum waste of material. All right, this is it for this update. I hope you like it.
Right, it is good I didn't made the holes on this side, only on this side for testing purposes and you know, and prototyping. Why it's so good? Because right now when I'm looking and when I'm thinking about it, you see, if I'm putting this somewhere here, it's let's see if it's staying there. So theoretically it should be center like that. So this side to equal this side pretty much. But you see how close everything is here. I made a secondary holes not on this side, but on this side here. So to leave space for each until the middle of the chip, I have to drag wires from the middle, pretty much from the middle to this guy, and to the next, and all these wires will start from the middle, and they literally have no space here around this area when all this bunch of wires from all these pins are intersecting there, you know, in this area. I can jump this the other way here, but I have a or jump this as well to this other side as well to leave more space. So this is an option, and to maintain this size of the board that I'm having right now. But the other option that I have is to enlarge a little bit the space to leave more room. Come on, something like this, you know, and have plenty of space here for the wires, for all these pins and all these wires. The wire is very, very thin actually, but I still don't want to intersect. I want to be a single wire to its corresponding pin there. So I will leave plenty of space there, and also here as well. I'm not sure if that will be a problem there. Probably until that thing there, or I will whizzle around on those pins on the margin. I will see how I will make it, but yeah, pretty much this is the idea, to leave a little bit more space here and also here for its pins. I'll have also to consider those fuckers, those problems that I have in the margins. And yeah, shit. I will see how I will make it. I have these two options, either to make room from here, or to leave some space here, or both of them, both these options. All right, what I did so far, I mounted all the other wires. I even color coded, and it did help me just a moment, some time ago. It helped me, this color coding, while I was soldering these pins here. At some point I missed one pin. I couldn't see it because it was a shadow or something, and I put, instead of here, I put it one step further, and because I was following the colors, when I got to green here, it was too it should have been on the first pin, the green one. And then I looked more closely and with more attention. I actually searched where I made a mistake, where I didn't solder one pin. I was looking for it, and then I see it, and I desoldered a couple of them, and I soldered them back as they should have been correctly, and everything is fine. Imagine if I didn't have this colored coding that I'm having here, and continuing to the last one and remaining with one in the air, and figuring and realizing that the first one was missing. Holy fuck, no? Holy fuck. And yeah, it did help me, this color coding, so I highly recommend it. Not this particular color coding, of course, but some sort of color coding. So far so good. I also mounted the pins on one side here, as you can see, but it remained this side here to mount it. What I did, I took my vise from here because it's not bolted in. I never bolted in. I leave it loose all the time. And now I want to show you how I'm preparing everything and how I'm soldering. I decided I want 6 pack of pins, as you can see, 3 and 3. You see, there are 6 here, and being 6 is enough to. I actually made a test with this line, with this row, or with this side. I mounted them here already, and I mounted them on taking them out, and one wire got loose, but probably I'm not sure if it was from the force I dragged them out, or just simply because the solder was too weak and it gave up from the soldering point. It could have been both cases. And let's see. So now what I have to do, I have to solder these brown ones here on their respective pin holder here, and I have the pins here already prepared, and I'm showing you how I'm doing it. I'm grabbing some solder on the tip. It's quite a bit of solder. I hope you can see. I'm inclining this on a side to be. I only need this side, of the pins to be prepared. I don't need the entire pin to be prepared. Only on that side. There it will stack. You know, I will stack the pins, the wires. I will have to bend them 90 degrees like this, as best as I can, and this one out of the way. This one as well, and one by one I will solder them. I'm not sure how well can you see it. I'm not working like this. I'm actually staying on the table flat, but for the video here I will mount it like this, and one by one, blip, blip, blip. You'll see it's quite fast. All I'm interested is to leave a good amount of blob of solder there, just to be sure it's soldered, you know. And all the wires are prepared already. I will not show how I'm preparing the wires. It's quite repetitive. You see? I'm using my tweezers all the time, especially when the wire is bent away too much. Of course, everything that I'm doing here is not absolutely perfect. It's having a lot of errors, you know. But because I can bend the wires, I can correct any kind of errors. And I don't have enough solder here, and the box is wanting to leave me to leave. All right. I'm putting plenty of flux there, and not every time. Come on, not. Stay there. Don't move. Like I said, I'm not doing it like this. Come on, don't move. Do not fucking move. It's moving slowly, the box. But until it's finishing moving, I will make the connections. And now I'm checking, I'm dragging the wire to see if the solder is good enough, and it is. All right, that's it. This is how I'm making these pins, and they are awesome. Actually, I use some scrapped pins here. I'm not sure how well can you see, but these are gold. I had this 6 gold and this 2 here, and the rest are white or silver. And these gold ones are scrapped. I did fucked up, if you remember, one line of pins, and I replaced them. 3 plus 6, it's 9 pins that I fucked up last time, and I replaced them with ones that I scrapped from boards. I don't have many. These are the scrapped pins that I have. I keep them in a small bag here, and in my box of treasures. And yeah. Okay, this is it. This is how I'm doing it. When I will complete this thing, it will be half done. When I will put all the pins in and mounted it here, it will be half of the project done. And I'm quite happy with how it's looking, and the spacing is quite right. All right, thank you very much. See you later. All right, I finished soldering the last pin holders, and I test mounted here. This is only for testing to see how it's fitting, and it is fitting fine, very well, I may add. And the idea of using only 6 pins is genius. Of course, like I am a genius. But in reality, in this capitalism, I can any kind of genius cannot get any kind of money in capitalism, because you know, women have priorities, and yeah, people like me who they literally want to do something, they are just stopped and not allowed by any means, by the government, by the capitalism, by the things how they are. You know, money is a big problem in modern days. It wasn't like this always. Anyway, this is my test using this prototype that I'm building here. Of course, probably I mounted it inverse. This longer side should be on this side probably. It really doesn't matter how it's put. It will matter when I will mount the chip. Here it is, the chip. The next step is to mount the chip on it. I can't believe it how good it is right now. It is looking like it's a piece of garbage. Everything. It's not looking probably aesthetically pleasing, but it is functional. That's the whole idea, is to make it as functional as I can. And for free money. This is for free, and I can actually use it not only for this chip. After I will finish testing, hopefully successfully. I hope it will be a success. I hope I didn't build this for nothing, for a failure result. And if this chip will be fine, I will remove this chip and leave all these wires for other chips to add. So this will be a universal chip holder for this kind of chips that I'm having here. Very fine threads, extremely fine pins that they have. Can you focus on you? Probably it's better to keep it there and to zoom in. You see, this is my finger, that's my finger, and those are the pins. Holy fucking shit, you see? Yeah. Actually, you can read on the chip, HT1621B. That's the number of this chip. If you were wondering, it's the driver chip for the LCD, multiplexed LCD. Okay, so that's the next step, and it is looking gorgeously. I like it. And I also leave some spaces here. I can actually get inside there if I really want to. I hope it will not be an issue. But from here, from the side, from this side and from this side, I can easily drag corresponding wires to other boards, and with the LCD chip on it, and make the connections there probably. And we will see. This chip is made actually for a multiplexed LCD matrix, but I will use it for LCD chip that is having very few number of pins. So theoretically, it should be very easy to drive because I have small number of pins. But internally, that's the problem. I have no idea how to do anything yet. I have to discover how this is working. From the datasheet alone, I hope it will be clear enough. Usually these things are ambiguous, especially on serial, and I hate serial communication. I hate it because it's very hard, very unintuitive. It's not user friendly at all. But I love parallel communication. I love it because it's very user friendly, extremely intuitive. The problem is that it's having a ton of wires, and it's pretty slow as well. But for what I need to do now, I'm thinking after I build everything, maybe I shouldn't have built all this. I probably could build a smaller version. Yeah, a smarter and smaller version for. Now when I'm mentioning that LCD chip that is using a few pins, I really don't need all this crap that I'm having here. I didn't think of it. Holy shit. Anyway, but it's good that I made it, because maybe I will use in the future something more interesting and driving with more pins, probably a matrix. Who knows what the future will bring. But this will remain in time, and if something will present, I have something to link to everything, you know. Maybe. Yeah, but the smartest thing should have been to link exactly the pins that I need from this chip, because I really don't need all of them. I really don't need them. Probably it will be smart. Check this out. Probably it will be smart, but I have to look exactly on the datasheet. So probably it will be smart to link only to put the wires only to the pins that I need here. That will be smart. Yeah, interesting option. Okay, all right, we will see. I have to actually consult the datasheet, see exactly how the pins, how many pins, and which are the pins to connect to each designated pins that I'm having here, connections, and we will see from there. Yeah, all right, see you later. All right, hello, from Romania, from your favorite artist electricist, Mr. Q12. And voila, actually rotated right now, it was inversed here, so I took it out and flipped it 180 degrees and push it back here, because this longer side should be on this right side as I make it. I was having all sorts of annoying elements, like one line here, some holes here, so I decided to put this customized piece of paper here and actually write down the pin numbers of the chip, actually, but also for this all wiring that I'm having here. As you can see, 24 and there 48, and all these mysterious markers that I put here, they represent the actual wire, if it's full color or if it's white. You see, this is also having this is also white color, but it's having a stripe of each white wire is having a stripe of color. And yeah, so this is full color, this is white color of the wiring, pretty much. You see, it's one full, one white, one full, one white, pretty much. And it's easier for me to it's easier for me to guide me which is which. And also I glued the chip, but I didn't glue it directly on this. I actually put a distancer, a couple of cardboards. Let me zoom in a little bit and show you like this. You see, if it's focusing correctly, good. So I have a pretty good distance. You see, it's a very good distance. It's floating in the air, pretty much, all those tiny little pins. Why I choose it like this to make it? Because if it's flush with this paper there, it will burn it, or whatever material is there, it will smudge it, it will burn it, and I don't want that. And if it's in air a little bit, it's not that much in the air, it's a little bit, and it and the wire should come out, should come off, and then bend to its respective pin. I made, so this is the progress so far. I didn't do much, but it is a little bit of updating. I made some pictures. So this is from the PDF itself. Let me see if I can find it here. I made a screenshot for this pinout. As you can see, is this chip HT1621B, and this is the pinout, and I made a screenshot there, and this is it. And I marked, after I made the screenshot, I marked with red the most obvious links that I have to make on my board that I'm having there, and with blue the ones that I was unsure if I have to link them, but it turns out they should be linked. So pretty much, as you can see, all this side is pretty much active with wiring, while this side is not active with anything. All the pins that I need for this 7-segment display multiplex that I have are 0 through 5. It means 6 segment pins, and also the COM pins. So in total there are 10 pins for the LCD. And for the chip itself, this driver chip, I need its power VDD, probably 5 volts or something. Voltage for the LCD on this pin here, which is 3 volts in my case, and VSS it means ground. So all these 3 are the power pins. And let me show you the circuit diagram that I find. Yeah, this is it. So here is the data. You see this 4, 1, 2, 3, 4, and 5 here. So it says application circuit, host controller. So these 5 pins here are also, they need to communicate with the microcontroller, MCU microcontroller. For the refresh of the LCD, this controller is having an internal clock. It is specified on chip oscillator. You see, there is this chip is having an RC 100 Hz or something oscillator internally. So I will not probably use this oscillator pin. Oscillator in input, OSC E, you see, and OSC out. But these 2 pins probably I shouldn't. But as a probably I will link all this side of the pins. I will link them to their respective pins. There are quite many pins here to link, but I made this image screenshot of it. I put it on my phone. I cannot show you on my phone because it's on this phone that I'm filming with. So yeah, that's it. All right, I'm not sure how well you can see. I only managed to solder 3 wires, and and it's unbelievable hard, mostly because the distance between the pins, where are you? The distance between the pins is exaggerated small, and I literally couldn't see anything. I put a piece of paper here, as you can see, to obstruct the things that are on the other side. You see those circles that I made there? They are very distracting. I cannot see if I cannot see exactly or precisely when I get a bridge between the pins. Of course, now when I'm filming with the phone, it's looking very good, but but the usual distance is like this. This is how I'm seeing it. It's impossible. It's almost impossible. I bring down this loop, and I center it like this. You see how yellow, this was white as this. You see how yellow is now. And yeah, I looked through. I'm not sure the camera if will let me check myself. Yeah, not fuck it out. Okay, so something like this it was. So this is the viewing, maybe a little bit, no, not that much. like this. So this is how I'm seeing it pretty much through the loop. And when I'm looking through here, kind of like that, I'm seeing it. So from here, looking like this is impossible to work. But through the loop, it's a little bit better. It's not ideal, but it's a little bit better. And I can actually see the motherfucker pin and the motherfucker bridge that's between the pins. And I had a ton of them. And I managed to make it, these are looking like they're together, but they're not. So I managed to unsolder and solder back again a couple of times. Only these 3 pins because it was a bitch to to solder them. It's very, very hard, but it's not impossible. It is possible to link them like this. And I will think on another and better way of linking those pins in the future, of course. But for now, I will continue like this. And hopefully it will be good enough. So that's my setup. This is my progress, what I'm having here, and let's hope I can finish it and have no shorts and no bridges between the pins. All right, see you later. Yeah, I managed to make to put the 4th wire. You can see it probably here. Here it is overlapping over the other wires. It's hard to see it, but this is it, and it's going there, and it's very, very, very. Now when I'm zooming in, it's looking like it's very easy to work with, but in reality, I didn't zoom in. I only used this loop that I'm having, magnifying glass, and this small one that is greatly, probably 30 times, and this is 10 times or something. And that 30 times small one really helped me, but I had to get it like this close, and I had to sneak my soldering iron between these 2 points, and it was hard to work. I was holding my hand something like this, you know, and no, not really, not a good position and not a good way of doing, and it's a high risk of bridging and making contacts between the pins. It's a very high risk with this maneuver that I'm doing here with these wires. It was a very good idea to lift up the chip from the surface and holding it in air as it is right now. It was a very, very good idea. It's a little bit hard to see. It's very hard also to see how to solder each pin there. There are shadows that are masking the true direction or length of the pin, and I made a ton of mistakes. I did solder not what I wanted to. It's very, very difficult this way. I really need some pads, some very, very, I'm not sure, probably this will call for another design, at least here on the surface, not the entire thing. Probably I will have to think about another way of mounting this chip to something, and from that something to drag the wires. So not to drag the wires to these pins that I'm having here. So as it is right now, dragging the wires from this output pin to that pin of the chip, it's not a good idea. It's a very hard thing to do like this. My belief is that I can do it, but it's very hard, and it's very is exaggerated close, and very, very easy to make short circuits between the small pins there. And now it's I have to redesign at least this part. I didn't think at all on the chip how it is mounted, the pins of the chip. I was having all this idea how to mount it on the breadboard, and it was difficult enough. But this part here, where I have to deal with the pins of the chip, I avoided it completely. So now I have to think hard how to do it next. Maybe I will continue with these wires because it's kind of working, but I don't like it. Yeah, maybe I will continue with wires, or I will have to redesign the entire thing. I don't know. Holy shit, it's hard. All right, this is it for this part. All right, so I have a couple of these transistor pads, T-pads, transistor pads for SMDs. You can see a little drawing. There is a SMD transistor on this pad. I know it's looking weird. So they are already marked with a crayon. You see, you can see it here. And I erased that crayon graphite marking from this two. They were marked as well. I can show you. Actually, they're looking like this when they are cut. And you see, I have. You see. Actually, you can see one with a transistor on it down there. And I scratch the copper with a very sharp needle, very thick and very sharp needle, and I get that layout that I'm having there. But for this thing, to get this precise, that's the problem. I have to be very, very precise, and also the thickness must be exactly that thickness between the pins. You can see there, and there between the pins, and also to leave a track as wide as the pin with it. And is and I tried the first one that I tried with the needle here. Then I tried with my cutter here, which is it's sharp enough. And I made this bull piece. It's like this. It's scratching like this, and when you scratch it in multiple directions, let me actually zoom in. Yeah, nah. And and the problem is that I don't care how clean the scratching is. All that I care is to get that distance that is between the legs of the chip and to maintain a single clear line. And by hand, so far from my testings that I did with, like I already said, with the needle and with the cutter, it's just piece of the bull. It's just like piece like that, and it's not good at all. So far, I have no chance of doing it. Or to do a clean cut in the copper for this. How many legs I have there? For 24 legs, it's an impossibility to make it by hand with the tools that I have, at least. The copper is quite thick. Of course, it's very thin. It's a pellicle. It's a very thin layer, but it's still thick enough. I cannot scratch it with one scratch and that's it, is interrupted. I have to do it multiple scratches, like I don't know, tens of scratches, 20, 30 scratches on the same line until I will scratch deep enough to separate the two sides. It's not good. So I need a mechanical thing to do. I'm thinking so far. So this will stagnate a little bit. This will hold up until I will find a proper solution that I'm trying here. And I am thinking on a solution right now, a mechanical solution with a motor and something. I also have these are my tools. Grinder here. This is a flex, and there is my lathe there. And I'm thinking to use my lathe because it's very precise, and it will not wander the cutter that I'm imagining to use if like this on a simple motor. This tip that I'm having here is not perfectly stable like this. It's actually wobbling like this. And I also have a disc also on a motor shaft like that, and it's also wobbling like this when it's rotating, and it's creating a very thick scratch, or the hole that is making is very thick, and it's not really that 1 millimeter like the disc with it. If the disc with it is like my finger here, the scratch is like 2 fingers or even 3 fingers, the scratch, because of that wobbling, and that's not good. With motors like this, for rough cutting and rough drilling, they are perfectly fine, but for precision cutting, not really good. But my lathe is very precise, so I'm thinking to make a tool with with a cutter blade or something similar, something like a cutter blade, very sharp and very thin at the point and here, and hopefully by rotation will scratch. And I need a feeder, something that will feed into and then drag it out from that scratching. That's at least that's my idea for now, and how to solve this problem. This might be transforming into a cutter here, but I will have to mount whatever I need vertically like this, and feeding up and down, it will be a problem. It's not really reliable. Okay, all right, that's it for this update. It isn't impossible until now. All right, this is my setup. My lights here are open. This is how I'm working. I'm looking there through that, and probably through this a little bit, just for checking. But for working, I'm more using this larger one. For this kind of pins and this kind of fragility and very close together, I kind of can work without any magnification magnifying glass, just with the naked eye. But my eyes are getting tired, and they are hurting very quickly when I'm concentrating. The bulb of the eye is actually deforming. The muscles are squishing the eye to concentrate on one single very tiny spot. And if I'm doing it for a few seconds, it's no problem. But if I'm doing it continuously for a lot of those pins, it's very demanding on the muscles of the eyes, and it's very nasty. So it's absolutely it is extremely important to use some sort of magnifying glass, or like I'm having here, this loop that I'm having, or a microscope. Ideally, I never had a microscope for electronics. It's not really a big thing, but yeah, these are my my two soldering irons. They are not powered, but I'm keeping them like this because they are. If I'm leaving them like this, they are slowly but surely going down like that and falling down on the floor. And I was thinking to add something here, like a V, and insert this like a V, but it's very uncomfortable here. So I find this new solution here. It's very cute. All right, so that's. I also tried this magnifying glass. Is very good. This 2.5 magnification is extraordinarily good. It's quite a big area. But unfortunately, I don't have 3 hands. I need 3 hands for it to hold it in hand, and with this hand to hold the wire, and with the other hand to actually solder. And and I need a fixed position magnifying glass here. So I am discussing about this thing here because I only managed to solder 4 wires, and seeing how complicated and extremely ugly was looking only from 4 wires that I linked there, I got scared and I interrupted everything, any progress, and for a couple of days. 3 or 4 days probably, and in this time I actually buy some boards, probably like this big, probably will be. I have no idea how, but they have. I discussed it already, and they have some very weird. This pinout here is not in line like I'm having it here. Is a weird pinout, but is easier to link wires from that deep pinout that is having that board to this pinout that I'm having here, at least, than to directly link the wires on the chip itself, on the pins of this extraordinary tiny pins of the chip itself. So that's today I got some courage or some craziness
some crazy courage I got, and I said to myself, let's continue to solder, even if it's crazy. If I have to intervene, and if one link that I'm having there is desoldered by some reason, I hope not, but if one in the middle there is desoldered, I'm totally screwed, because everything that I'm doing here, I'm doing it on this side only, and I'm progressing down until I will reach the last pin there. But if I'm having a problem in the middle there, holy fucking shit, I don't think I am able to solder one single pin, well, wire to the pin, and not desolder the other to near it. So that's a very big problem. How I'm soldering, I'm not using, I am using this solder iron that is for soldering, actually, is catching solder on its tip. Now it's closed, as you can see. It's not working. I can put my hands here and there's no problem. So I'm soldering with this iron. I'm preparing the wires. So I'm cutting the wire to the length that I need. I scratch the ends of the wires, both ends with this knife, and then I prepare those scratch ends. I prepare them with this solder that I'm having right now in my hand, here and there, but not on the pins. I'm not using this solder on the pins there. For that, I'm using this other one, which I modified a little bit. I put a piece of, it's looking like it's iron, but actually it's copper, and it's heavily oxidated. That's why you see it like that. But it is copper, trust me. And this copper doesn't, usually when you think of copper, you believe it will get full of solder immediately, but it's not the case. In my case, this copper wire that I'm having here, actually this solder is exceptionally good for cleaning between the legs. So this is catching the excess that I'm having there, and it's kind of strengthening the solder on the pin. And this is with this guy, I'm actually soldering the wire to the actual pin, and it's very, 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 very hard. It's a bit harder than usual because it's so tiny. And and how can I explain it? I don't know how to explain it. If this yellow pen that I'm having here is the actual pin, the wire is like this, is in air, is having a certain distance to the pin. But being so small, I don't see this distance, and I'm kind of trying to touch the pin of the leg of with the wire and kind of sense it with my hand, but it's so tiny I cannot sense it right away, and the wire is either bending out or squished in other direction, or it's still in air, and I'm kind of guessing when is touching the actual pin. And when I'm soldering, it's a mess. 50% I'm doing it by luck, and 50% by actually looking and seeing what I'm doing. But it's kind of 50% because I'm not really see what is going on there exactly, even with this, especially through this lower resolution or lower magnification glass that I'm having. Through here, I can see it very, very good actually, but I have to get extremely close. So right now I'm having it quite at a distance here, and I can insert quite normally my hand on the tool. But if it's too close, everything is getting very hot very quickly, and it's being very close. This entire device is not allowing me to enter there and to solder properly. If I'm choosing to use this magnifying glass, this magnification that is quite strong. It's very strong actually. It's very good, but I wish I had higher magnification like this one for a larger distance. That's it's a problem. I have to deal with it. I'm using it after I finished soldered the wire to the leg, and I'm checking it. I'm lifting it up like this, and I'm moving it around. You see, and I'm moving it there, and I'm looking through this magnifying glass. Of course, if I can, yeah, like that. If it's focused, yeah, you see, and it's I can actually see exactly what is going on, and especially the most important thing, if I'm having bridges between the pins. That's the most. That's the thing that I'm looking, and also how the weld is going on. So that's how I'm working. That's how I worked so far. And this is the progress. All right. Wish me luck to actually finish everything, the rest of the pins, and only this side. I need only this side, and that's it. After this, the other side, I don't need it, fortunately. All right. That's it. Thank you very much, and see you later. One another detail is that this glass magnifier is actually distorting. I'm not sure how well you can see, but when I'm looking at that finesse, that's very, very small thing that I'm having there, is actually distorting it a little bit, and I have to literally move my head left and right to see the actual pin, how is from one side and from the other side, and is a bit more harder than usual than with your naked eyes. You know, that's another problem using magnifying glasses like this. It's very good, it's helping me, but there are some inconveniences. All right, the craziness is done. This this was crazy. This was crazy hunt. So I finished to link every pin. Well, it's not every pin, it's because actually I can zoom in like this with my phone here. Yeah, the first two is what I was looking here. The first two pins, I didn't catch them. Actually, I can see exactly here. They are not connected as well, but every other pin are connected. So we can read here from 24 pins on one side, I connected only 22 because only 22 I need. The rest I don't need. So thanks God. Thanks God, I don't need them, everyone. And right, and this you should, I don't know how to. Do you see how close to it's almost like it's very, very close. And I had to insert there the iron, the hot iron and everything. And it was so close to my finger, it was starting to burn my finger by looking through the magnifying glass. I don't really understand, or I don't care the distances a little bit. It was a little bit too hot. So I had to kind of move quickly in the same time, unprecise. So it was, you have to think a little bit three-dimensionally, because let me actually zoom in here. I put an eye, only one eye through this loop, very, very close to it, and with the other eye I was closing it, and I was looking very like in cartoons almost, you know, like the eye was elongated like that, you know, looking to that. That was a little bit comical. For every pin I did it like that. Also, you have to let me zoom in a little bit more. I hope it will help. This is what I'm seeing with my eye, actually, like this, and it's very good as you can see it here in the camera, but in reality you have numerous obstacles. You have to be aware this is a three-dimensional command focus. This is a three-dimensional soldering, in the sense if you look through this side here, you will probably see something that is overlapping, but if you are looking from the top, is not overlapping anymore, and you can see some pins are further pushed back or further pushed in. It's okay. Like I said, it's, if you move it like this, you will have the impression they are overlapped or touching the pins, but if you are rotating it, you will see it's another story. And I did rotate it on all on all possible sides. Right now I am rotating it very slowly. You can barely understand it is rotating. And I did rotating it specifically to see if I'm having bridges between the pins, because it's extremely easy to make bridges of solder between those pins. So I think in comparison, this is my my nail, my fingernail, you see? And it's almost like my nail, as long as my nail, or like this probably. Yeah, kind of. Almost. Tiny bit longer than my nail. So, holy fucking shit. I'm very happy I managed to link everything, all the pins that I needed. It was a crazy idea, but I said to myself, I have to push it, to link all of them, because because I want to test it. Let me drag it here. I want to test it. This chip I want to test it in conjunction with the Multiplexed LCD that I have. I buy already those boards for this kind of chips. I hope the pins on the boards are exactly the pins of the chip. I really hope so. This is SSOP. I actually written here somewhere SSOP, and I bought TSOP boards. I didn't find others, only this, which were very cheap. And I hope the spacing between the pins is good enough from this chip to those boards. But until those boards will arrive 1 month from now, from yesterday, I really want to test this chip with that Multiplexed LCD, and most probably with Arduino, and to test how this motherfucker chip is working, how hard it is to drive it and to use it. If it's easy to use it, it will be cool. But I doubt, I highly doubt it. It will be easy to. I believe it will be very hard to drive it. But we will see. Until then, so far so good. I managed to link it here. To this prototyping board that I made it manually, everything, of course, as you can see, and it's a beauty. It's a beautiful thing, and a very extremely hard thing. And yeah, I put there a piece of paper, but I can take it out now because everything is already mounted, I hope, without disturbing anything important. With my needle here, and that. Come on, yeah, get out, get the fuck out, like that. Okay, so I put this piece of paper because I wanted to protect this side. If my solder was slipping down, and it did slip down a couple of times, and also to have a very white background there, because I have those numbers, and also a little bit of shadow will. I cannot see anything if it's a little bit of shadow, like it is right now. I must. It's absolutely imperative. It's absolutely necessary to have very good light, and very good. And good enough. I mean, a little bit of magnification, better than your eye. You know, something that is better than your eye. And voila, this is it. This is finished here, and I'm very, 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 very happy that I managed to make it like this. I actually discovered a solution. If one wire got loose, actually I kind of had a little bit of luck. Let me zoom in to actually show you better. So I was trying to solder the last pins here, and one wire, I didn't see it. I swear to God, I didn't see it. And when I put my soldering iron, I put on the next pin with the wire already soldered, and I tried to solder my new wire on that pin, and it desoldered the last wire that I had. So what I did, I couldn't hold it there in place. I couldn't. It was impossible to resolder it as it was bent like that. So I desoldered it from here. I strengthened the wire a little bit, and I resoldered it back to its place, and then I put my new wires that I had, soldered them on their position, and then dragged them, and paying very good, having a very good attention to be the correct wiring from the pin to this other side of the pins, and that's it. Okay, so that's the discovery that I made. I have to take it out from here and strengthen the wire, and then resolder it back. But if it's like it is right now, it's almost impossible. Probably I will have to take out all the others and then to solder. Holy fucking shit! I hope nothing will. I mean, I hope everything is soldered good enough. And I did test it. Everything. I
I drag the wire with my tweezer here, and I move it like that to check if it's properly soldered. And from my tests, it is properly soldered so far. But of course, it's very, very fragile. What I'm having here is extremely fragile, so I should better put a case on top of this, not to by mistake someone else, like my father, start to grab the wires and make a little musical instrument from it. All right, that's it. Thank you very much for watching, and see you later.